Join now. வால்யூம் வருதான்னு வேணா செக் அவுட் பண்ணிக்கோ. நான் வேணா இங்க பேசுறேன். ஹலோ, ரெக்கார்டிங் ஸ்டாப் பண்ணி வேணா கேட்டுப்பாரு. கேக்குதுல்ல? Am I audible?
Sudha is audible.
Good morning.
ம். பேசுங்க அவங்க எனக்கு
Good morning.
கேக்குது.
Good morning, all.
Suganya ma'am? Ma'am, can you hear me?
Ma'am, good morning. Ma'am, am I
Yeah,
audible?
yeah. Good morning, ma'am. Good morning.
Sorry, ma'am. I think I
No
sent you
problem.
YouTube link rather than a
Yeah,
Meet link.
no problem. That's what I was wondering. Okay.
Shall we start, ma'am?
Yeah, you can.
Nimla, shall we start?
Yes. Once again.
Please start.
This is the audible.
You need to raise your decibel a little bit, Nimla.
Yeah. Doing it. Good morning to all. A warm and yes. Yeah. A warm and pleasant happy morning to all present in this forum. To all the faculty delegates present on the virtual forum for the 5 days FPP by Department of Computer Applications, Hindustan College of Engineering and Technology.
Yes, Nimla.
I request our beloved head of the department, Dr. A.R. Jayasudha, to welcome the gathering.
Hope I'm audible to every one of you.
Yes, ma'am. You are audible.
ஆயுதம் செய்வோம் நல்ல காகிதம் செய்வோம் ஆலைகள் வைப்போம் கல்வி சாலைகள் வைப்போம் ஓய்தல் செய்யோம் தலை சாயுதல் செய்யோம் உண்மைகள் சொல்வோம் பல வன்மைகள் செய்வோம். Very good morning to all connected here. I trust every one of you and your family members are doing good at health. Thanks to the technology that connects all of us virtually here and aids us and let us to progress in our own way, though we are geographically distributed, turning all the blockings into stepping stones. I welcome you all for this 5-day faculty development program on machine learning using Python. Every day we need to hone our skills, and the need of the hour is mandatory that technically we need to update to survive in our career. Upskilling has become a day need these days. In this context, our department has arranged for 5-day faculty development program on machine learning using Python. In an hour or two, we would be exposed to many of questions related to or our doubts getting clarified related to machine learning. I wholeheartedly welcome our speaker of the day, Dr. G. Sukanya Karunamurthy, Associate Professor, the Department of Computer Science and Engineering in Vellore Institute of Technology. She is also the Assistant Director of Software Development Cell. Welcome you, ma'am.
Yeah, thank you, ma'am. Thank you.
Thank you, madam. Thank you for accepting our invitation. She's highly experienced and an expertise in the field of data analysis. Thank you very much, ma'am, for spending your time with us this morning. I wholeheartedly welcome all the participants, professors from other colleges. Dear participants, my sincere thanks to all of you for your responses. And participants and the honorable resource person of the day, actually, you are our energy. I welcome our staff members. My thanks and appreciation for the effort in making due arrangements for the smooth execution of this program. My humble request to all connected here is to make use of the session to its fullest. Thank you for the opportunity. Thank you very much. Looking forward for the session. Over to you, ma'am.
Yes, ma'am. Just a moment, ma'am. Just one minute.
Yes, ma'am.
Ma'am, is my screen shared? Am I
Yes,
audible?
ma'am. Yes, ma'am.
It's shared, but your voice is a little feeble,
Yeah,
ma'am.
yeah. Okay. Is it audible now?
I think you will have to raise the decibel a little more.
Yeah. Is it okay now?
Okay. Okay for me.
Yeah. Is it okay for others?
If any of the participants can respond, if you're comfortable with the decibel.
I think they are unable to mute. Okay.
Ma'am, you can a little bit increase, ma'am.
Yeah.
Yeah,
Okay.
thank you.
I think I have.
Yes, ma'am. Now it's clear.
It's clear. No? Okay. So, a good morning and a warm welcome to all the learned group over here. So, it's always energetic, and we feel always enthusiastic and energetic in sharing whatever knowledge we acquired through the course. And my sincere thanks to Hindustan College and Jayasudha ma'am, Nirmala ma'am. We always have a very great, what to say, relationship in sharing our knowledge between us. As Jayasudha ma'am rightly pointed out, COVID has brought in a lot of disturbances in our day-to-day life, and also equally it has brought in a lot of challenges by which we could understand the strength within ourselves. So always keeping the right track of taking only the positivity that prevails in every pandemic or any situation. So we have to move ahead with whatever challenges we faced and the solutions that the technology has brought in. So now the context for the day is about machine learning, and I could see that it is a continuous 5 day session, and the delivery is very crisply made. And today it was only about an introduction to machine learning modeling and the complete installation procedure for the softwares that is required to proceed with. So, since the programming and other stuff is going to get covered by from tomorrow onwards, I thought I can better make you think why we could move or why we should move to understand this, because everywhere if we move ahead in our life, you open a YouTube channel, you open up your Facebook account, Instagram, or whatever it is. If what we could see is only an ad about learning artificial intelligence, and this is becoming mandatory. So when something is being thrown to our space continuously without intention or without a question, we are normally move ahead towards the concept. So let's try to explore. So being in the learned community and being a teacher, and we should be in a proper position, because now if you see, since every BSc graduate and even 10th standard student is learning about what AI is all about. So we should have a proper technology understanding on what it is and why it has to be brought in into this much limelight, that the entire world is moving towards that. The application is vast, and if you look at every industry, I'll try to touch upon the major industries that we cover as part of our consultancy, as part of our
Ma'am,
research.
sorry to disturb,
Yeah.
ma'am.
Yes, ma'am.
Ma'am, little more decibel is required as there is little noise from your end.
Oh, I do. 1 minute. I have kept it in the full. Yeah, is it clear now?
Okay, ma'am.
Yeah, is it clear?
Yeah. Okay, ma'am.
Yeah, because it is in the full swing. I have kept it in 100%. Okay.
Okay, ma'am.
Yeah. So so that is the necessity, right? So this technology is one of the disruption that happens in the field, where the world is trying to entirely move towards complete automation rather than the human involvement. And we every one of us could have heard about the recession that happens in software industry, and the basis being the introduction of artificial intelligence. So this AI concept may it is actually, whenever a computer technology was brought in as a replacement or as an automation, automatically there will be pros and cons into the human lives. So instead of taking in the cons of it, let us take it to the pros and try to move ahead in our life to make our life better. So in that way, let's try to understand in the next, I think 1.5 hours or more. Let's try to explore and understand what best is machine learning for us, and how can we move ahead into by taking it into our shoulders. And this is what I think I can talk you about, and I'll touch upon deep learning and optimization also, because all put together is what we call as AI. And we'll look at the introduction and machine learning categories, Python, and discussion. So, what's intelligence? Okay, so sometimes always there is a confusion why artificial intelligence is required. Okay, so the system can able to do all sort of activities when you are able to write a program. Then, in that sense, why is it required? Right? It's not always that a machine needs to do something, rather a human is always preferable in many places, and we look comfortable also there. If and the machine was brought in, let's say for example, if you are able to unable to process something like 15 lakhs 20,000 plus 16 lakhs 70,000, okay, a machine can easily do that. So by that terms we assume that the machine itself is intelligent. Then why artificial intelligence methodologies are necessitated to be brought in? Okay. So then that is the next important concept that we have to clearly understand. Let me give you very simple examples. So earlier, if we look at so every one of us would be told about the arithmetic progression and what to say, the geometric progression, right? So a human skill set will be basically analyzed by these kind of analytical skill sets. And when it was told in uh, just a minute. Nila? One second. Okay, sorry. So, when we are asked to calculate what is 20 plus 3, the answer is very simple, right? 23. So, and when we move ahead to increase the number of, that is the digits that exist in that, okay, it is becoming little complex, but our mind will take a minute of time and automatically gives you a solution. And as and when you start increasing, okay, so if you move like this, it is becoming little tricky for us to understand. So when we are asked to calculate what is 20 plus 3, so what is 20 plus 3, what is 23? Okay, so these kind of additional operation, at least the number of what is provide, it is look at the digits that exist in that. Okay, it is becoming very complex, but our mind will take a minute of time and 20 divided by 3, and these and as and when you start increasing the base or the next why we are needed to tricky for us to understand. So the addition we are asked to calculate what is 20, when so what is very simple, what is 20? Okay, let's say it is additional operation, please the number of our lines provide, it is but as and when the digit look at the digits and if we are in need of it is look at these participants, our mind will take a able time 20 divided by 3 solutions, and these and as and when you start increasing the base with or the next why we are in needed to tricky for us to understand. So now when we are asked to calculate what is 20, so what is 23, what is 20? Or let's say it is additional operation, sometimes from the lines provide, but as and when the digits look at the digits and not only what happens, look at these participants, our mind will change a very 20 divided by 3 solutions, and these as and when you start the base with or like why we are a leader for us next understand. So now when we are asked to calculate what is 20, so what is 23? So when we say let's say it is additional sometimes from the lines provide, but as and when the digits look at the digits and not only what happens, so the these participants are why will change a very 20 divided by 3 solutions, and these as and when you start the base with or like some parts of what next understand. So now when we are asked to calculate and hence here so what is 23? So when we say let's say it is additional but as and when the digits look at the digits and not only what happens, so the these participants are why will change a very 20 divided by 3 solutions, and these as and when the base or like some parts of what next understand. So now when we are asked to calculate and hence here so what is 23? So when we say let's say it is but as and when the digits look at the digits and not only what happens, so the these participants are why will change a very 20 divided by 3 solutions, and these as and when the base or like some parts of what next understand. So now when we are asked to calculate and hence here so what is 23? So when we say let's say it is but as and when the digits look at the digits and and not see, okay, so it is why is the change of the Nirmala and how the way, but now so now we are asked so what is so automatically I'll try to present 9 as my number. Okay, there are many more possibilities. Let's say it may be like 1 squared plus 3. Okay, then it may be like 2 squared plus 3, the next number, which will be 7 again. 2 squared is 4, and then plus 3 would be 7 again. But the concept may differ. Okay, and if I ask you for the next number in the sequence, again it will be 10. This will be like 4 squared, which is 16, and this will be next different thing. Okay, 3 squared plus 3, 9 plus 3, it will be equal to 12. And all these combinations are possible through the activities that is happening within our brain, where nobody is concerned about. Okay, so and that's how the next number comes and arrives at our brain. Okay, and is there any strict restriction on it? No, it completely depends on the pattern that your mind identifies from this corresponding sequence. So, but how will you identify? Okay, so the next question is, if there are multiple possibilities, how do you ensure which is the next possibility? What is the next method of arriving at a perfect solution? There are many possibilities. Okay, either you make increase the number of inputs. Okay, so 1 4 if I restrict, okay, so you have 3 possibilities as of now, but it may get increased. But if you increase one more number in the series, 1 4 9, okay, now your concept gets shrink. Now it is not like plus 3, here it is plus 3, here it is plus 4, sorry, plus 5. Okay, and now the possibility gets reduced. It may be like 4 squared, which is equal to 16, or it may be like plus what we say 7. Okay, and when I increase to the next number, let's say 1 comma, when I give the sequence like 1 comma 4 comma 9 comma 16, again, okay, the number of possibilities get shrink. So what we need to understand is the what is required, okay, to identify the next number in the sequence, which comes out of a logical thinking, is the pattern identification, right? So this pattern identification nobody can restrict. Okay, so your mind may think in one way, my mind may think in another way, the next person mind may think in another way, and no one can say which is right and which is wrong. But you can restrict and you can say that this is the proper pattern when you have enough number of data sets. What is a data set? It is nothing but the input that you give. So when you have proper inputs, then automatically you can that is automatically you can say that the accuracy of the number may get increased. Okay, so that is what we need to understand, and what is expected is to have an accuracy. Now why are we discussing about it comes into picture now. Okay, so earlier the computers, if you look at the computers, have only arithmetic, ALUs. Okay, ALU stands for arithmetic logic unit. Arithmetic stands for plus minus division. Logic stands for and, or, and not. Okay, so and, or, and not. So arithmetic and logic operation are the only ones the system can perform. But now what we expect is to have this analytical or logical thinking also, or aptitude thinking also, to be brought in as an intelligence into the system. So when these kind of pattern matching is expected, that's where is the position we move on to include an intelligence. And this is what we call as artificial intelligence. And as you know well, the system has only ALU and it cannot be intelligent of its own. But you can bring in that intelligence into the system by means of your coding. Okay, so how do you bring in that intelligence? Again, we need some coding, or we need some kind of context to be brought in. So that's where we end up with the requirement of artificial intelligence principles. So the two diagrams which I kept in is to indicate that the maturity, the accuracy will increase only when you have maturity. So when this kid looks at 1 comma 4, it has multiple possibilities. Okay, but when a person sitting over here looks at 1 comma 4, he may ask you what is the next number in the series, and then accordingly he may bring in what is the next output. Okay, or next number comes in the series. Okay, so as and when your experience grows, okay, experience is nothing but the maturity that we acquire through our knowledge. Okay, and as and when we grew up, okay, so our mind is capturing all different inputs that comes from the external world, and it tries to find out what is the best solution that can fit in for your input. So what is expected is to make your computer to behave like this matured person rather than behaving like a kid. What the kid will do, it will just react to whatever it is taught. Okay, if you tell him that it is 1 plus 5 is equal to 7, this kid will tell you like so. Okay, but this person will not do like so. He will question you back on why the reason has come. Okay, so artificial intelligence is all about trying to make the system to behave like this matured person rather than to that is behave like a kid who is actually working only on the code that we write. If you instruct a system to state what 1 plus 5 is equal to 7, the system will do like so. That is traditional programming. Okay, it actually behaves like what you are, oh, that is it actually behaves based on the instructions that you give. But this is intelligent enough, and the entire world is in need to move ahead to understand your intelligent technologies. So what is actually okay we are going to talk about today is about these three. So there is a human and there is a machine. So this human beings actually, we need to come closer to this machine in all the respects that we want the machine to exactly be a replica of the human being. Okay, so this machine, let's say nowadays we have restaurants serving using robots. Nowadays we are in need of people, robots to serve in work. Okay, so wherever the human being inputs are or the human being applications are, so we are in need of the support from the machine. So how to do that? So you have to bring in the intelligence of a human being into the machine. Okay. So that experience that you gain when you are able to bring in, or when you are able to feed it to the machine, that's where is the necessity of this AI. And looking at the AI principles in detail. Okay, so this is actually the scenario that you all would be looking at whenever you have artificial intelligence starts in a very broader domain. It includes many technologies like the inclusion of search techniques, the inclusion of optimization, the inclusion of fuzzy logic, okay, everything. And you have a machine learning inside. Okay, so this artificial intelligence has machine learning to arrive at the pattern understanding. Whatever we have discussed now, okay, so you are given with the input, you have to understand what the pattern is, what pattern exists within that input, and you have to arrive at the output. And that is the purpose of machine learning. Okay, and this machine learning has a subdivision inside which we call it as deep learning. Okay, and now the entire world states that deep learning is the recent trend. Okay, other than your machine learning. Yes, why? Because this machine learning, again, it is completely automated, and that is what we call it as the deep learning. Deep learning concepts are very similar to machine learning with the only addition of automation that I'll elaborate to my understanding to you. And this is the broader picture that everyone needs to clearly understand, because when you say that you are working on AI technique, it also includes that you are working on ML and you are working on DL. We cannot really distinguish between. So when you talk about AI is the cover layer over this machine learning. Okay, so you write some algorithm to identify the pattern. For example, when I say 149 16 25, what is next? This machine learning can give you 36. Okay, but 36 as such, the output you can need not to be given by artificial intelligence. It can add up a cover layer stating what is the best output that it can match. Okay, that is what we call it as AI. So this diagram I specifically mean to say that we need the machine, okay, to actually work like a human being. Okay, so this calculator is used by the human being. We want the machine also to use this in a similar way. So by that, so how do we do that? That is by the inclusion of AI technology. And let me try to take you to a difference between this machine learning and deep learning by a very simple example with our own understanding as a teacher. So this I have given in other sessions. Hopefully, if you have understood my session, I think it will be a replica. Now, so this is a pic of a diagram, sorry, a classroom environment where the teacher is actually demonstrating an activity to the set of students. Okay, the students, or this is the current situation. Okay, before pandemic, all even if the FTP is going to get conducted, we have to sit in one place, and then there is no provision to be online, and there is no provision to have a virtual environment on a 90% case earlier. The classroom environment has many understanding and many advantages. Okay, let's say you have a teacher. Okay, the teacher is completely aware of the listening skill about each and every participant. For example, some students may be very smart enough. When I taught for the first time itself, yes, this guy, he can able to understand in a very well manner. Okay, but this guy may be little slower in understanding. Okay, he needs twice the explanation as that of the student, for example. This teacher, as a teacher, and looking at this person, okay, he can able to understand what proportion is to be given to him and what proportion of teaching has to be given to him, and this goes in sequence, right? And the listening skill is one criteria that we all try to understand from the student set that we have in our classroom area. Other than that, what else? See, these are the things that we acquire from this corresponding classroom, that's it. Okay, and we can understand the interest areas. For example, somebody may be good in listening to lectures. Okay, so you look at this girl. Okay, so he is interestingly looking at the board, and he's maybe interestingly looking at the lectures. And if you look at this particular girl, she is not looking at the board, meaning that she may not be interested in lecture, rather she may be good in practicals. Okay, and for her the interest area is mostly towards practical. And this guy, for example, if he doesn't even look out his back, meaning that he doesn't want to sit in the classroom. Always he'll be running roam around looking at quizzes and all the competitions. So the interest areas of each and every particular student differs. Okay, and that is also a teacher can capture. And this is attribute one, characteristic one, and this is characteristic two, which the teacher can capture from this particular environment. Third is the understanding level. See, when I'm teaching, I can look at the eye contact. I have an eye contact with all the students, and looking at the eyes, I can deliberately can able to say, okay, so whether the student has understood. He is smiling, yes, we could understand. When I'm that shrinking my face, okay, the teacher may understand that I couldn't able to understand. So the understanding level is one more parameter that we take in from our classroom. And similarly, you have many. I just have put forth only four. The style of learning. Okay, somebody style of learning varies, and if you look at the teaching learner perspective, you have auditory learners, you have visual learners. Okay, somebody may be good in watching, interested in watching videos. Somebody may be good in watching audio. Somebody needs only classroom environment. Okay, so this is one criteria which you can. So all that what we have understood is this is an environment from which you are able to understand. For example, the student one, okay, what is his listening skill, what is his interest area, what is the understanding level, and what is the style of learning. Okay, so this we can record for each and every student, and this goes in automatically without our understanding or without the explicit requirement. As a teacher, this is stored in our mindset. Okay, and this goes in for all the 70 or 60 students that you have in your place. So what we do in this traditional classroom, you are creating this particular data in your mind. Okay, so this data is what we acquire from this particular classroom, and this is being processed. Let's say if S2 is not performing well on a particular case. Okay, so we'll move on to the next slide. And this is the data that you collect. With this data, what are we going to do? Okay, so sometime we that is once the teaching is going on. Okay, intermediate, after a month we try to conduct exams. Why are we conducting so? We need to understand, or we need to assess. Okay, so what is the performance of the student? By the way, we can understand how good are we in delivering our task, what is the modification that is expected. Okay, Not every student can able to acquire 100% as in our first sitting of exam. Okay, but what we expect is only 100% performance. So initially the student may not able to get, the deviation is more. Let's say he acquire only 70%. So what we do, if he is a student S2 sitting in our class and he acquired only 70%. So what we do, we'll try to understand where he deviates, and the deviation can only be acquired only from the four characteristic that you observe. You find out that he is very good in visual, and you may not have supplied proper video learn materials to him. That is maybe one of the problem that he may encounter. So what we do, we'll try to think what is a problem that may exist with him. We will plan accordingly. What's a plan? And we can, our mind will think of, okay, what can we add some extra materials to him, can we give counseling to him, very different factors, and accordingly we'll act. Let's say after doing this exercise, okay, he is going for second round of exam, let's say second internal or something, and his performance gets increased. Now again, it is not to an appreciable level. Okay, it increased, it is only 75, and this process will definitely continue, and every time there will be an improvement in performance. And sometimes he may jump from one level to other level. This is 80, this is direct 95, let's say. Okay. At one point of time he will reach the maximum what is required. And keep in mind, it's not always 100%. Not every student is expected to have 100%. It may be 98 or 97, which you think you are enough. Sometimes it may be 90 even. Okay, so whatever is our target which we set, if the student is able to achieve, that's what is the expectation. I think this is a very simple process that we normally do in our day-to-day environment. And this is the whole picture that talks about this. Okay, so these are all the exams that we conduct. So we try to find in the intelligence. Okay, and when we can, we try to, because there is a deviation in the intelligence that we observe between the students, we try to apply many methodology. So, and finally, but what is the result that we require is a steep increase in the performance, or a continuous increase in the performance. Finally, when you achieve your target, what you are targeted at, you stop the process and you say that you have succeeded. Okay, so this is traditional environment. But what is happening in, because you assume, suppose if I meet you all in Hindustan College for a lecture, okay, so this much, when I talk something, when I see that a student cannot understand, or let's say a listener cannot understand, automatically I can stop. I can find out what is the problem and I can answer. But this is what is happening now. Okay, so this environment is what we call as virtual environment, or an online classroom, where I'm sitting somewhere, okay, trying to utilize the technology and trying to deliver the context. Again, I'm a teacher. We should not tell it as a teacher now, it is a mentor. This mentor, okay, I'm sitting here, I'm assuming that I have lots of students sitting somewhere. Okay, don't think like I'm talking like a student. This is a classroom environment, I see. And all those who are listening to me, I never know, okay, what your understanding level is, and or what is your interest area, or you, what is the style of learning. Okay, none of the characteristic I'm worried about. Okay, as such, what I do, I'm a mentor. My task is to deliver the context. Okay, so I'm sitting here, I'm delivering my context, and I have lots of people. Let's say it is 250 people who are sitting here. Whether it you are watching or not, I never bother. I assume I'm just throwing my part to you, and it is your duty. Let's say, okay, for example, by the end of fifth day, suppose if the Hindustan College is arranging for one quiz, okay, to assess whether the understanding from this 5 days event is correct or not. Okay, so what happens? You need not to listen only to my lecture. So the data is versatile now. Okay, what we do is, you will try to understand. Your necessity is to pass this quiz. Okay, so what you do, you will try to gather knowledge from many areas. How are you gathering? Nobody knows. Okay, so every person who is sitting here is unique, and they will try to collect data from in whatever way they want. But again, what is expected is to have a steep improvement. Okay, so whether it is an online environment or a classroom environment, we never bother. What is expected is to have a continuous improvement in your performance. So how this is also, Okay. And why are we talking about all these things? Why do I talk about this traditional classroom environment? Now we are trying to relate it. Okay. So we have seen two different environments now. One is the traditional classroom environment where it is mostly teacher centric. The teacher is completely responsible for understanding the students, and if at all any changes are required or any additions or modifications required, you have to bring in that. Okay. And by the way, the target is to achieve 100% or near to 100% accuracy. That's it. Okay. And there is another environment which we call it as learner centric, where it is distinguished to be a virtual class. Okay, where we do not bother about how the patterns are identified or how the attributes are being taken. I'm just throwing my data, and it is the duty of the learner to pick in from whichever resources you are in need of. Okay, and in whatever case, whether it is teacher centric or learner centric, learning is what is happening. Okay, here the teacher is mostly responsible for this, but here the learner is mostly responsible for this. And machine learning is all about this. Okay, machine learning is a kind of teacher centric approach where your algorithm has to understand the or the it is the duty of the data scientist, okay, to identify what are the characteristics that contribute to the decision making. What is it characteristic here? It is the understanding style, learning style. Okay. What is the understanding level of understanding of the people? So these becomes the characteristic or the attributes. Okay. So when this needs to be identified properly by a data scientist, and accordingly the output has to be mapped. Whereas if you look at in deep learning, we don't need to bother about anything. Rather, I say that the student S1 is available, S2 is available, S3 is available. So it is the duty of the algorithm to pitch in the characteristic of all these things. Identify what are the characteristics that are common across all these things. Okay, the algorithm, you don't need a data scientist to identify the feature. Okay, rather I am in need of an algorithm that automatically does that for it. But again, once the features are identified, you will have a matrix. Okay, which after it has to go to a machine learning based algorithm. So that is what is the difference between machine learning and deep learning. That's why this DL is put inside machine learning. Okay, I hope the context is clear. Basically, DL also use machine learning technology, but the feature selection alone is the duty of machine. That is a data scientist in machine learning. The algorithm automatically does that for you in deep learning. And in short, okay, how do the machine learning and the deep learning does? Okay, so what we require, so you are conducting test. Okay, and what you need is 100% accuracy. So what is expected for that? Okay, how does this particular guy reaches 100%? So he initially learns with what? Learns with some data. Okay, when the test is conducted and when you find that there is a deviation, increase the learning. Okay, and then when there is a deviation, still increase the learning, and this will go on until you require the required accuracy. So what is machine learning or deep learning in short? Okay, so we should have a set of experiences. What is it? Experience, it is the learning that you get on a specific domain. This learning can be different for different scenes. Okay, so I can show you one simple example later. So this experiences are different. Okay, so and this experiences has to be proper and perfect, and the number of experience also has to be proper and perfect for you to move ahead. With this experience, what I do, I'll try to understand myself. Okay, I have an experience. Let's say I'm riding a bicycle now. Okay, I started riding a bicycle in the age of some around 10, let's say. Okay, in my age of 10, when I start learning, I would be told to look at straight. Okay, so that I will not bend my hip and fall down. But after some time, let's say, as and when my age group grows, okay, I will have learned a lot of things. How does this experience grows? It is through the way I pass by. Okay, later on, I understand that whenever there is a what to say, a stone in front of me, I have to slightly take a right or a left depending on who is coming behind. Okay, there are a lot of experiences that come. As and when your experiences grow, your learning will happen. And With this experience, I will do a task. What is a task? As in my case, when it is cycle, I'll go for a ride for some 2 kilometer. Okay, and how do I assess my task? Okay, I have an experience, I say that I'm performing a task, I should not stop with that. Okay, in this case you're writing a test. What is the purpose of test? Okay, it is to assess yourself. How do you assess? It is by using this performance metrics. Okay, you need to have a performance metric. And what is my performance metric? What is the time taken for my 2 kilometer ride? Okay, whether I have come down in this 2 kilometer ride. Okay, all the stuff that you can set as a target for you becomes the performance. When this performance is not appreciable, then you can go back, increase your experience, do the task, and then again it can be assisted by performance, and then again it can go, and in a cyclic way it will go, and then accordingly it will go. Okay, and this is what we call it as machine learning or deep learning. Okay, where comes the difference now? I hope the context is clear. This experience collection and the feature selection, okay, so is by the data scientist in ML. In DL, the feature selection goes automatically being done by the system or the algorithm, but only the experience collection is done by the machine. And with that, when we look at the traditional, the difference between traditional and the machine learning approach. Yeah, ma'am, am I audible?
Yes, ma'am. Yes,
Yeah,
ma'am. You're audible, ma'am.
yeah, thank you. So now to move ahead with the slight difference between this traditional and then the deep learning approach or the machine learning approach. Okay, now you have in traditional programming style as of now, without using this AI based approach, what we do is to a computer will try to give the program and the data. Okay, I have given a very simple example. So this is a program to get input in Python. Okay, I'll write a 4 lines of code to get two numbers as input and apply an equation or to compute its sum, and then I'll try to print the sum. When I give 5 6 as input, this 5 6 only be passed here. It will not be intelligent to understand whether it is integer or string. Okay, so normally it gives me 5 6. If, let's say if you assume it gives you 11, it will be 11. And if your input is different, let's say it is 10 20, okay, you will have 30. So no other output will happen rather than just the performance of arithmetic or logical operation. Okay, so here it is the program and the data that you give as input. Finally, the output is what you are expecting. Okay. Now coming to the machine learning. Okay, so the context is entirely different. You have the same computer with the ALU now, but what is expected is this computer has to be thrown onto an environment just like that. Okay, it has to collect experiences, it has to identify the pattern, just like how you did 1 comma 4, 1 comma 4 comma 9, okay, 1 comma 3 comma 5. These are the inputs that I give, and I say that 7 has come, and I say that this has come, this has come, and I want the machine to understand, okay, what would be the possible pattern that may give you the output. So now what we do is we'll just try to give the data and the output. Okay, so and then we'll try to ask the computer to understand how the output is being derived from this corresponding data. Okay. For this data, so what we do is we try to give this as the input. 5 6 is 11, 2 3 is 5, 3 6 is 9, and we want the computer to intelligently understand what could be the relation between this. Okay, and in simple terms, this is an addition, so automatically we are in need of one such. Normally the output is not a program of this kind, rather it may be a pattern like an equation or a tree in some cases, or a corresponding parameter matching, vice versa. Okay, so this data and the output is what we give, and that exact difference lies here. Okay, so the system has to understand what is the system. Again, it is nothing but the algorithm that you write as a developer, that we write, and the necessity of machine learning in the algorithm is to find this pattern that exists between this input and the output, and it has to bring in a program as the output. So this program, if I give 10 and 11 as output, it has to give me 21 as the output. Okay. So that is what we call it as machine learning. What happens? Why is it called as machine learning? Because earlier it was called as traditional programming. Okay, we are creating a program, and the system performs according to that. Now the context is machine learning, where we want the machine to learn based on the input that we give. So it is input to output matching, and the machine tries to learn from this and tries to throw out output. Okay, so that is what is the necessity that has brought in all of us to learn this particular platform. And in short, what we do is we are doing learning, okay, and we want the machine to learn. And for this learning to happen, we are in need of the materials. Okay, this materials is what we call as input. Sorry, this material is what we call as input. This input can be different inputs. Let's say it can be an image, it can be a video, it can be a voice signal, it can be number or anything. You may give any input, and this input, okay, from this input you have to understand. So this we call it as attributes. Okay, so the input has to be converted into a lot of attributes. Attributes are, let's say, for example, when I give an image, okay, of my face. Okay, when I give my face, it has to understand what is the length, the distance between the eyes. Okay, what is the breadth of my nose, and what is the color of my skin. Okay, all that becomes your attributes. All that becomes your attributes. So our task is to identify what are the attributes that contributes in the decision of this image. Okay, so then with that, what we do, we will run a machine learning model. Okay, and we will try to understand the result of the model. What is that result? It is nothing but the performance. Okay, so this performance will be analyzed, and when there is a deviation, we look for the improvement strategies. In what way can we improve? Can I give a clear picture? Okay, whether the contrast and brightness are to be improved, or whether multiple images are to be supplied, or am I wearing a glass and am I trying to find out what is the distance, what makes the things go wrong, and then you have to understand the improvement strategies. And then this improvement strategy, okay, I identified that the image is not proper. Okay, and you need to bring in some improvisation on the image, and accordingly you have to find out how you can bring in that improvisation. Okay, you may have lot of ways, you have to find an innovation. It is, should not be just like increasing brightness or sharpness. Other than that, you have to find in what are the different ways you can possibly bring in this innovation. And with that, we will try to rerun the model to reduce the number of failures. Okay, and then again the input changes if there is a requirement. Changes in the sense you will have image 5, image 6, and it goes on, and the pattern goes along, and then finally the learning happens. And it is a simple difference between this machine learning and deep learning. In machine learning, these features are identified by the data scientist, whereas in deep learning, if you look at this, the features are identified by the model. Rest of all is same. Okay, you have performance metrics, and you have hyperparameters, nothing but the parameters that you can change to bring in a improvisation in the model. Okay, that's it. So with that explanation on what AI is and what deep learning and what machine learning is all about, we can end up this introduction with a small quote. Okay, in deep learning, what we do is we'll try to leave everything to the hands of the machine. Okay, so it is this section of a human being which is computing everything, tries to find out the match in the, let's say if I ask you what is this, you can readily say it is a robot, but it has nose, it has mouth, it has eyes, and all the stuffs are there. Why can't you call it as a human? Why are you calling it as a robot? Okay, so that is the important difference that our mind strikes out. We have something on our mind to state that it is a human, we have something on our mind to state that it is a robot. Who decides that? It is the neurons that presents in our brain. Okay, we already have enough observation on how a human being's skin will look like, and it doesn't look like a human being's skin, it is looking like a machine, and hence we call it as a robot. Okay, and now the same is expected from a machine. But what deep learning states, leave everything to the brain of a machine. And who does this? Again, it is you, who is the human. The human is going to write the code for doing this analysis. Okay, and that's what we call it as neural network programming. Okay. And this programming is what we write as part of our algorithm, and we say that we leave it to the hands of a machine, and that's what we call it as deep learning. So it is very important for a human to understand and write algorithms, okay, to behave like a human being, to make the machine behave like a human being. So that's where is the necessity of this machine learning and deep learning, and when to use this machine learning, when not to use. This is very important. Okay, and it is not that, let's say, if someone tells that I have I have written a program to convert INR to US dollar. Okay, and I have 1 lakh clients. Okay, to whose salary is in INR, and I want to convert to US dollar. Can I go for a machine learning? Definitely not. Okay, so it is just repetition of loops. That's repetition of a particular task. The static task cannot be taken as part of a machine learning. So what comes as part of machine learning? When a task cannot be computed by human expertise. Okay, cannot be computed in the sense all the things can be computed by human expertise, but it is that it needs lot of time and effort, which is ultimately, and you need the accuracy will go off. Let's say if I'm asking you to compute this expression 15264 divided by 2342, okay, and I need the result in 5 point decimal. Okay, the accuracy of our calculation will definitely be very lower when we go for a machine. Okay, and when I ask you to find out what is the next number in the series for hundreds of different patterns, rather than relying upon a human being, you can better go for a machine. Okay, because it will not get tired of doing something. So that task is, whenever a human expertise is not possible to do a task, you can better go for a machine learning. And when that a task will consume exhaustive human expertise. Okay, when you feel like a human expertise takes too much time in understanding the logic, and you may have again a question of this also needs too much time. See, it is simple application of this and come up. But here what we mean is it needs lot of energy to understand the background of the particular problem. That's what. A task cannot be explained by human expertise. Again, this is the next important thing. A human expertise cannot explain why he arrived at a particular solution on many cases, right? So, but in when you tell that something is an output, you should be able to explain why it comes. Okay, when such case is not there, you can go for machine learning. A task needs to be adaptive to different entities. This is very important. Okay, so if you look at the online shopping platforms now, you have recommendation systems that are running. Okay, if you open, and if your spouse is opening sitting in the next system, if a friend is opening sitting in the next system, every one of us have different items displayed on the screen. And is it that all different patterns are being displayed or given differently? Definitely not. Okay, so it is all runtime activity. When you open up, it captures your area of interest just by storing what is your preferences that you have given, or the in the what is the way that you have searched, and all that interest are being captured. And hence you need it to be very flexible and adaptive to different platforms. And when the tasks that are based on very large data, okay, of course, big data is what we have. Let's say a movie review has come, and you need to understand what is the rating, okay, from among the 1 lakh or 10 lakh reviews that are given. You can better go for machine learning rather than a human mind. Okay? So human mind will always be biased, rather a machine cannot be biased. Okay, so having understood these things, we'll move ahead to understand what data is, what data set is, and what's an input, what's an output, and we'll end up with the categories of machine learning algorithm. What is a data? Okay, everything that you have with you, okay, without processing is what we call as data. Okay, now if I say, if I write 5, it is a data. Now if I write hello, it is a data. When I go write something on my YouTube page in a simple word, it is what we call as data. And when it is a Facebook, when I say something like now my friend has a birthday today, when I write happy birthday, it is actually a data. when I record something on my WhatsApp, when I say that is when I send it as a voice message, it's a data. So it is not processed. Okay, you are generating data, and these data gets generated through a variety of means, and nobody can stop it. Okay, you can just generate, and it is going in an exponential way. Okay, and when these data gets aggregated based on one common domain, it becomes your data set. For example, yesterday a movie X got released, for example. Okay, all the data that are pertaining to this, be it a review or a comment or whatever it is, or a rating. Okay, if you accumulate all these things that has very similar characteristic, we call that to be a data set. Okay, so data is the input that you are getting from the real world, and when you combine it and put together in one domain, we call it as a data set. And this data set can be divided into input and output sometimes, or you may leave it as such, taking that it is just an input, and we'll see what makes the difference. And accordingly, your data set category will variation. When you have input output, we call it as supervised. When you don't have segregation on input and output, if everything looks alike for you, all the attributes looks alike for you, we call it as unsupervised. Okay, and this is one simple data, okay, which you can actually think of. There are four different values that you have: the time in seconds, the solar irradiance, the ambient temperature, which is the prevailing temperature that is there, and then you have an electric demand. What is the demand? Okay, demand of electricity, that is, so we assume that this electric demand is an output depending on three different characteristic. Okay, the time, which starts with 12 p.m. at night. Okay, and the solar irradiance. Okay, and the ambient temperature at that particular time. So this particular characteristic or the attribute depends on three different attributes, and hence we call this to be an independent attribute. This is depending on other, and these we call it as independent, because these are not depending on itself, rather it contributes to a decision on this particular attribute, and this we call it as independent. And this is what we call as independent, and this is what we call as independent. And when you have independent attributes, and this is what we call as inputs, and this dependent attribute is what we call as output. Okay, and this is what data set is. Everything is a data. See, 0 is a data, 28.7 is a data, 630 is a data. When you put together into one particular domain, we call it as data set. Okay, and when you segregate depending on the dependency or not, we call it as inputs as well as output. Okay, I hope it is clear. Now, how will you measure? Okay, so how to do that? Okay, how will you identify how to make up my data? I'll start with a very simple term. So, how do I create my own data set? Okay, so before getting into this scales of measurement, I'll just explain how to create my own data set. So, the very practical example is to understand how the COVID is being understood. My intention is to understand whether a person is infected with COVID or not. That is the yes or no. COVID infection is there or not. Okay. I need to understand what are the different parameters that are contributing to this decision. One parameter is the fever. Okay. Second is the cold. Second is the breathing trouble, and then body pain. Let's say. Okay. You may have a numerous number of attributes. So how do we assess? It is by means of the domain knowledge. Okay, initially when COVID came in, these parameters may not be understood, but later on it got understood and it got added to the attribute section. So this is 1, this is 2, this is 3, this is 4, and it gets added. Finally, you can add, and this list will grow on as and when the domain knowledge increases, as and when so tastelessness may get added. Okay, and you may have shivering in the body, itching in the body, and these are the factors that you identify as and when your domain knowledge gets increases. That's it. So when a patient P1 comes, okay, so you will try to record what is the output of all these parameters, and you will say whether it is yes or no. Okay, so this is whether the patient has fever or not, cold is or not, breathing trouble is there or not, your body pain is there or not, and whether the person is infected with COVID or not. Okay, likewise, you will try to record for P2, P3, P4, and it goes on. Okay, And this becomes all the data that you record normally in the form of a m cross n matrix. Okay, and this is what we call as two-dimensional table. Okay, so this two-dimensional table is what is be the result of all the um, what to say your machine learning models. Okay, the data set will always lies in this format. Even if you take an image, the image will get converted into this style only. Okay, and when why do we call this as complex data set? Because okay, all yes, it is yes, all no, okay, it may be no. Okay, but what if the combination or this may be yes, but for the same guy you may have no. How do we decide? A human brain cannot. So as and when you have 100 patients, okay, at least for you to observe the reality, it is fine. But what if you have 1,000 patient data, 10,000, 20,000, 1 lakh, and it grows? It will be difficult for us to understand the pattern. What gives us yes, what gives us no between this. Okay, and that's where we end up with machine learning requirement. Once the data set is understood, now we go for understanding the scales of measurement. Again, this is important. So, what is scale of measurement? Okay, fever is what I need to measure. Okay, how do I measure? There are multiple ways in which you can measure. This is a binary value, yes or no. Okay, either yes or no will come. What is yes and what is no? Is there any ranking between these two? Whether which yes is holding a very high range and y is holding no is holding a very higher range. Depending on that, we have nominal as well as ordinal scale. Nominal scale, items are assigned and there is no ordering among the groups, meaning that y and no doesn't have any priority among that. For example, when I ask you to fill what is your sex, male, female, others, there is no priority among this. Okay, all are equally treated. That's what we call. On the other case, it is ordinal scale. Ordinal scale means when you say, okay, so when there exists ordering among your values. For example, when I ask you what is the feedback of my teaching now, okay, you can give in the range of something very high. It is very good, okay, or good, or fair, okay, or bad, very bad. Okay, how do I decide on this? Okay, when I say very good, yes, the impact is more when compared to bad or very bad. Okay. There exists priority among the values. When there exists priority, it is what we call it as ordinal scale. So the scale understanding is very important to arrive at a data set. So when you go for creating your own data set, you have to understand what is it. Okay, so what kind of scale measurement are you going to use? So, and there are two more scales, but we will not use it in machine learning. It is interval scale. Interval in the sense, from morning 6 o'clock to evening 6 o'clock, what is the value? From evening 6 o'clock to again morning 6 o'clock, what is the value? Okay. So these intervals. So when I ask you for, let's say, how many people have visited the showroom from morning 6 a.m. to evening 6 p.m. and how many have visited from morning 6 p.m. to evening early morning 6 a.m. Okay, when I want that is what kind of operation. So let's say this is 10 people, this is 20. What kind of operation is possible? When I ask you how many persons in total has visited the showroom, you can go for addition. How many more has visited during the night time rather than in the day, you can go for minus. Only addition and subtraction is possible, but 10 star 20 will never do. Okay, so this operation is not possible, it is on the interval scale, but the ratio is something different. Okay, the ratio is okay. I have this is mostly on sports domain, you can very better understand. So this guy is twice this guy's run is twice as that of the previous match's score. Previous match it is 100, it is for twice as that of the previous match, it is 200. So what is possible is to have multiplication and division, but these two scales, it is very 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 rare to utilize in machine learning, but normally only the nominal and ordinal scale will be used. Okay, and this is what we call it as the matrix format that we do. So A, B, C, D, E are all attributes, and these are the values. Okay. If you look at the value, again there are many types of values. So this is there on one scale, and there are two different types of data that I have given. This is one, and this is structured in the scale. You have attributes and you have rows. This rows and columns. Okay, rows and columns are, this rows will grow as and when you have the experience. Experience means the addition of data. Your new patient comes in, new patient comes in, automatically your rows gets increased and it grows. But when you look at here, you are looking at all the best. What are you taking? Here and all, you don't have any particular structure to say that this is the syntax of the semantics of the same sentence, and this is the number of words that you can have on a particular case. Okay, and this is what we call it as unstructured data. Okay, so this is structured and this is unstructured. It is little tricky to go for unstructured data. It will be it needs a lot of understanding, and mostly we use NLP for processing this kind of data. But on the other scale, the execution of this or the processing of this is comparatively easier. Okay, and this is structured and this is unstructured. And looking at the structured data now, you can have variety of data, that data formats that you can have: number, string, boolean, date, image. You can have signals. Okay, and anything, and you have whatever you want nowadays. The data set has, or the your database has the provision to actually store it. And there are looking at the data that you have on your data set. Again, there are two types. One is continuous, another one is categorical. Okay, continuous is when you have the possibility to have value. So you have the possibility to have the value between a particular range. You have the possibility to use it within a particular range. Okay, for example, okay, so the marks of a particular student, the marks of a particular student can range from 0 to 100. So anything in between can be called as a mark. Okay, for example, 99.5, if I want, that is also a mark. 98 is also a mark. 95 is also a mark. 10 is also a mark. Okay, and looking at it on the other side, okay, you have categorical value. Categorical is when you have only definite values that are coming. For example, nowadays the schools and colleges are not following marking system, rather it is a grading system. Okay, grading means I might have got three grades: A, B, C, and then an F grade. Okay, A may get matched to 90 to 100. Okay, and then this may be to 70 to 90. This may be to 50 to 70, and less than 50 may be to F grade. And any of these four alone can be the part of a particular attribute. Okay, it's not always everything. It's only the for any of these four, and that's what we call it as categorical. 1 minute, please.
ஹாஸ்டல்ல ஒரு யாராவது வந்து அது லைன்ல அப்டேட் பண்ணிட்டாங்க.
Okay. Phone switch off. Hello. Ma'am, am I audible?
Yes, ma'am. Yes, ma'am.
Yeah. Okay. So that's where we end up with categorical data. So either your data set can have continuous values or it can have categorical value. Okay. And the any data set, if you look at, those are the only two types of values that can present. But continuous, you can have only numbers. Okay, because the series of values can happen only in number. But when it is categorical, okay, so you can have both numbers as well as string. For example, A, B, C, F can also be like this, or you can have 1, 2, 3, 4. Okay, mapping to A, B, C, D. Okay, that can also happen. In any way, we call it to be categorical attribute. And having understood this, okay, now I think you have an idea of what data is, okay, and what data set is, what type of and what an attribute is, okay, and what type of data can be stored in your data. So with that, you will be building a structured database like this. Okay, and this we call it as the rows, we call it as experience, the columns we call it as the attribute. Okay, so once this data set is built, now the next level is to understand what kind of algorithm can I use, okay, to understand the pattern. Now I have 1000 rows of data. Depending on whether you are able to divide your attributes into input attribute, whether there exists dependent attribute or not, it is called as supervised or unsupervised. If you could identify at least one dependent variable on your data set, we call it as supervised. This dependent variable is otherwise called as output variable or response variable. if nothing could be done, if you all say that it is just a data, okay, and if you are not able to say whether something is dependent on other, it's all equal and it's all equally weighted, we call that to be unsupervised. When you have supervised learning, depending on when you have supervised data set, what supervised data set, your attributes can be divided into inputs and output. Depending on what type of value you have an output. On output, you can either have continuous value or you can have categorical value. When it is continuous value, we call it as regression. What is continuous value? You have a range 0 to 100. Okay, all values can be taken. We call it as regression. When it is classic, that is on the other case, when we say that only fixed values can come, it is called as classification. So this is when you have only discrete values, specific values on the output. We call it as classification. So how to do that? I'll just give a small example on how to understand. For example, this is a crowd watching a football match. For example, let's say, okay, I'm trying to collect data from this. What are the types of data? For example, for let's see, I'm just collecting a data like this. Okay, the first attribute is whether the sex of the person who are sitting inside, the age of the person who are sitting inside, the color of that is what to say hair who are sitting inside. Okay, and then you have something wearing coat or not. And I suppose in case I have the fifth column stating whether they are a regular visitor or not. Okay, suppose if I assume that this regular visitor is depending on all these things which I already have in my database, and if I assume that this is an output variable, okay, I say that these are all the inputs or the independent values which is contributing to this regular visitor, because the data is already there in our data set. Suppose for every football match, if they are repeating, I may want to give discount or something. Okay, so that is what we call it as supervised learning. Okay, when you have the provision. So, but if what if the other person looks at the same data set and I say, okay, age, color of the scarf and coat wearing or not, the face also doesn't contribute to regular or not, I also assume that this is an independent variable. I don't feel any relevance or the dependency of this particular attribute over the prior attributes. That's where we end up with unsupervised. Unsupervised, everything looks like a data which is of same priority. Okay, so this priority is the same. The priority of this age, sex, color, coat wearing, and regular, everything, all attributes are same for me. Why should I bother? Okay, that's where we end up with unsupervised data set. And what you can do with that unsupervised data set is to find out which of the rows looks common. Okay, and you can group. And this group in machine learning terms, we call it as clustering. Okay, so clustering is nothing but grouping the items based on some or other kind of similarity. Okay, how to identify the similarity? That's where is the necessity of your clustering algorithm. And there are variety of algorithms that we have for all the cases. Supervised, you have regression and classification. In supervised regression, okay, you have linear regression. In basically in supervised category, you have regression, you have classification, and then under regression you have linear regression. Actually, non-linear regression is supported by varieties like decision tree, support vector machine, and anything. And you have classification, and this decision tree, naive support vectors are basically for classification. But you need to carefully understand if you are a beginner, all the algorithms can give you only a number as the output. And this number, for example, any student who's writing an exam can be evaluated only for mark. Let's say if it is 89. So if my requirement is to leave 89, it is what we call it as regression. But if I map it to a grade like A, then which is called as classification. So all the algorithms basically can be treated as a regression algorithm. But over the last output layer, if this can be mapped to a discrete value, then we call it as classification. Okay, And looking at the unsupervised category, you have variety of clustering mechanisms. So how do you may wonder why, what makes the grouping very difficult? Okay, it's just grouping. Okay, it is not just grouping, since the complexity or the volume of data is very large, and the number of attributes are also very large. As and when it grows, the size of the data grows, the dependency of each and every attribute grows, the similarity of the context is what we need to carefully understand. So we have variety of algorithm. You have k-means, where the mean of the data will be considered as a major criteria in grouping. Okay, when the mean is too limited, too less, we say that those two are, for example, 2 and 4. When I say, okay, when the mean of these two is very less, lesser than my threshold, I understand that both can be clubbed into one group. So similarly, mode, when it is classic, that is what to say, categorical. Okay, so for example, I have 100 students. Okay, I want to categorize them into three divisions, three groups. How do I do? Depending on the grades that we secure, that may be one particular chance, and that's where we end up with K mode. Mode is nothing but the maximum number of repetitions that can happen. Similarly, you have variety when it is K midoid, means or prone to, or they are exposed to outliers. Okay, when there are too many deviations on the end, it may deviate your decision. On the other scale, this midoid will not be like that. Okay, so this midoid is something that is not prone, or that is not that is reliable actually. So it arranges all the data into in ascending order and takes only the middle point. And you have hierarchical DB scan and many algorithms. As and when your days progress, you may have a better understanding of that. And you have ensemble. Always the industry grows in that way, right? You have one type of application, and you have another type of application. We may wonder, what if we tries to bring in the advantages of multiple technologies. Okay, the technologies or the methodologies can be taken from either the same set. Let's say I want to combine decision tree with Naive, linear regression will support vector. Okay, or it may be on both the cases, like regression with clustering. Okay, that is what is ensemble. Ensemble means hybrid. Okay, how are you going to hybridize that? It depends on how we think. Okay, so you have random forest, as the name implies. Forest is nothing but group of trees. So this group of trees is formed by decision tree. So you construct decision tree 1, 2, decision tree 3, 4, and come put together. That is what we call it as random forest. Add a boost. When do we require boost? If we are if we have feel like we have lack of energy. Okay, and if there are 11 players playing cricket on a team, and if five of them feels they are, and if the coach feels like five of them need energy, boost can be given only to those five. Okay, and we do not need to give it to all the people, okay, who are already energetic. That's what ADA boost does. It boosts only the people who are actually in need of that. So whichever is performing lower, only for them the boost will be given. That is ADA boost. Okay, and this is gradient boost. Okay, again the boost has to be given to all those who are deviating in their gradients. Okay. And in short, if you see whatever we have covered, okay, till now, the modeling process goes in like that. You have real world entities generating the data. Everything is generating the data now. Okay, you have uh, from 1 minute. 1 minute, sorry. Hello. சொல்லுங்க. ஒரே நிமிஷம். Ma'am, is it visible?
Yes, ma'am. Screen is visible
Yeah,
now.
sorry. So all real world entities are generating data. Okay, so these data cannot be used as such normally. So we need to pre-process it. Okay, so the images that are coming. So basically, everyone can understand what the meaning of pre-processing is. In machine learning, there are a lot of techniques which we call it as EDA, exploratory data analysis, because all entities are generating data. The data may have be proper or wrong. It may be a junk data or it may be anything. So when these data has to be pre-processed for proper processing after that. Okay, and this data, it will be looked in for the necessity of having all the features. Okay, for example, I have a student profile at our university which has around some 40 plus columns. When I look at all those 40, something may not be of interest to us. Okay, and something may not be of interest. When my perception is on the grade that the student will acquire on a later date, okay, the pin code may not be of use. The state from which the person is may not be of use. Okay, I may, when I go for modeling, I can cut down those particular features which I feel is unwanted, which will not contribute to the decision making. And when you feel like so, you go for dimensionality reduction. Dimension is nothing but the number of attributes. Let's say this data has 40, you may reduce it to 20. Okay, it depends on what kind of dimensional reduction are you using. In either case, when the data is given to training, you can train the model using the selected model. How do you select the model? First, you need to understand what type of data set is it. Is it supervised or unsupervised? Okay, if it is supervised, now you need to understand what whether it be regression or the classification is what is required, and accordingly you have to identify the model. And then once this model is done, trained, okay, so you have to test. Why test? Because we saw three activities: experience, task, performance analysis. The experience is what you do from here till this part. Okay, experience collection. And then you are doing a task, you are training the model, you have the model, you do a task. What is the task? It is what is the action that you do using the particular. Then you now test the model. How will you test? By using the performance metrics. When it is regression, it is different. When it is classification, it is different. Depending on the task that we do, we will try to test for correctness. Okay, and then look at the result. If the results are appreciable, yes, we can stop, or else you have to go back. Okay, again, you think of what we done, whether we should go for a better pre-processing, or we should retain some feature, or should we change the modeling, should we add some features. Okay, all that we can think of, and you have to repeat. But in short, this is the modeling process that is there. Okay. On for the rest of the things, I'll leave this. One second. For the pages. So looking at the different packages that we have to understand, I'll shortly show you how we can start installing Python and other IDEs that are required for machine learning. But these are all the different packages that one should be aware of before starting to implement the machine learning algorithm. So the packages goes like this. It is very simple. These are the only simple packages that we need to understand. One is numerical Python. Numerical Python, the necessity being always we are going to use only matrix operation. Okay. This matrix operation is part of mathematical library in different programming languages. The same here, numerical Python is a package that is meant for doing all sort of mathematical operations, analytical operations. You have pandas. The necessity being always, as we told, the relational data structure goes in like a tabular pattern. Okay, here you have rows relating to attributes. Here you have rows relating to experiences, and this is what we call it as a data frame. Okay, you are fitting a data onto a frame, and this is what we call it as a data frame. and you have to bring in, suppose if this is stored in an Excel file or a CSV file or in a particular data, this has to be loaded into the system for exit evaluation, and that's what is the pandas will do. Okay, it is an easy package to make you pull in the data from your system, do the processing, and puts in back to your required place. Then visualization is very important, right? In data analytics, visualization plays a very major role. And there are two packages. Many packages are there nowadays, but basic packages are PyPlot and Seaborn. Okay, you can plot, and then Seaborn is an advanced library written over PyPlot, okay, for visualization. And the final thing is all the ML algorithm. If you want linear regression, logistic regression, decision tree, okay, you have Database. Everything is inbuilt and available as a package in this SQLR package. Either you may code, or to start with, you can directly start using on these algorithms. And these are the packages that one should know. And the platform that we have to understand for a very huge data. Okay, for example, you have a lakhs of data that you have, and you're struggling with your system to move ahead. You have inbuilt packages. Okay, everybody would have heard of about TensorFlow and Keras. Torch is PyTorch is also one library, and Theano and Cafe are very old libraries, but still they are also efficient. These are libraries or packages that is giving enough support to proceed, and these are what we call as the different. These are the different platforms that are available to you for easy evaluation. And these three also one should be aware of. Okay, we have a central processing unit in our system which has an inbuilt processor. Okay, you may have Pentium processor, Intel processor. So you may have dual core, quad core, or any IC core processor. Okay, but it will be okay to some extent because of the involvement of matrix operation. Here, everything will be considered as a matrix. Matrix to matrix multiplication is tedious. Everybody knows. Okay, it has lot of. For example, if you take 5 star 3 itself is adding 5 3 times. So if you look at this matrix of size 1000 cross some around 40. Okay, look at the number of computations that we have per unit of time. So it will be very large and the CPU may not able to process it. There we go for GPU, graphical processing unit. Because when you are working on the sport, there is games in your system, automatically the refreshing rate of your monitor is very high, and automatically a GPU will definitely support that. So even GPU may not be sufficient for some higher cases. For example, let's say I have 1 lakh pictures, okay, of a particular disease, and I want to find out, or I want to train the machine used on that. CPU and GPU will fail. There you go for tensor processing unit. Okay, it is tensor processing unit where one particular data will be assumed as one tensor. Okay, and these are available at free of cost to a particular extent on Google Colab. Later on, we have to procure it, and we need to buy a high-end system. And this CUDA a support is given in Colab. It is a parallel computing NVIDIA architecture. And when you have, as I said, 1,000 images also, it will be splitted depending on the number of cores available. And later on, the result will be combined. Okay. So I think I'll come back here. I think I can show you how we can start with the implementation. So initially, actually, basically, if you see, there are a variety of ways in which we can start working with this Python. Okay, I'll show you in my system. I have installed Python IDLE. This is a basic IDLE architecture. Okay, so and this is an interactive environment. Suppose if I type 8 plus 3, it will give me 11. Suppose if I type print welcome, okay, that's it, and it goes. Okay, if I want to write some program, yes, I can create a new file. I can start writing like this. Same program I'll write. So input of, okay, Takes what is the number I am in need of, and it gives the input. And I am in need to copy it. Then I'll come back and say what is the second number I have. And now the context is to print it sum. So I'll have number 1 plus number 2. Finally, I need to print. Okay, this I can do, and this is another type of it. I can save this as a file with .py automatically. It will take my first program, okay, as py. If I execute, if I go to run this program, okay, it will ask you for the first number. Suppose it is 2 3, it gives me as output. Okay, this is an basic core Python shell which all of you should install and make it ready. Over this, you can install all different types of packages. Okay, suppose if I need to understand whether I have a num4 numpy, see the module is not identified. I don't have numpy installed with me. So you need to go to the command prompt and you have to install. How to install? The command is very simple. You may need your system to get connected to internet, and if it is Windows, you have to use pip install the package name numpy. It is should be on the command line where you have installed this Python. If you do that, every package. So NumPy requires or Pandas requires NumPy. Python requires NumPy. So you have to install each and every package in sequence. Okay, and sklearn needs all the 4 packages to be installed. And this is one way which you can start working with when you are a beginner to a Python. And how to install it? Just you go to Google, okay, Python download. Actually, there are 2 different versions. Python 2 goes in differently. Python 3 goes in differently. You prefer having Python 3. 2 has a different syntactic support. Yeah. Just if you go to python.org downloads, you can download this Python library and you can just install it. Okay. So this is for Windows. If you want to have for Linux or Mac, you can just go. And if you are having a Docker image, if you are in need, yes, you can. Okay. This is one way. Now, I may feel little difficult to install package one by one. Okay, NumPy, and then over which I need Pandas, over which I need sklearn. And if I'm in need of Flask for the next day, I have to install. Instead, I have another option. Okay, we have Anaconda. So this Anaconda, if you see, and this is a kind of platform. This is what we call it as wrapper. Okay, they already have installed IDLE, over which they have installed all the packages, and they gave you as such a particular case. If you install, I have already installed in my system. Okay, so if you download, it will get downloaded as an Anaconda exe. When you install, it will give you a lot of IDEs. Okay, the important being Jupyter Notebook. Okay, this Jupyter Notebook, if you see, it will take a minute. And then another important one is Spider. Okay. 2 IDs it gives you. One is this Jupyter Notebook. So this is the Jupyter Notebook. I hope it is visible for you. I'll just increase a little bit. Yeah, it will run on a browser. Okay, it will run just on your browser. I'll just expand and show you. Okay. If you see, I can create a new Python 3. So new Python 3. Yeah, this is the Jupyter environment. If you see everything, we call it as a segment. Okay, this segment can be a code block or a comment block. If I want to write a comment, okay, welcome to all. Okay, this will not be executed. Even if you run, it will just stand as a static text. And it has also double hash if I write. Okay, it run as a it will come as a header. Okay, so this is like a comment. This is a block, and this block I can just write number 1 equal to int of. Okay, and then I can write the second statement like int of. And if you run it, it will ask you for the first number, it will ask you for the second number. Okay, now next I can just type what is number 1 plus number 2. Okay. print out some. Okay, again, if you execute this, okay, int space. Sorry, sum is equal to. I missed it. Okay, now if I write number one product is equal to number one multiplied by number two, then print product. Okay. I can just run this. Let's say I'll show you the advantage of this Jupyter notebook. Then 7 I give. I don't need to run this segment. Okay, I can just skip it and just run it. Okay, you can just see. Now I have executed the first this segment and then this segment. Okay, and it goes in that flexibility it gives. And if I want to insert a cell ahead of it, yes, you can. And I can just change it to a text cell. Okay, multiplication segment. Okay. So this is the advantage of Jupyter Notebook. If you want to import, now I have all libraries with me. Import NumPy as NP. Okay. Now if you execute, yes, it has given me. It has executed. It doesn't throw any error, meaning that I have all the things. This is again one spider environment. See, I have written a program. This is also like an ID. Okay. I have written a program, fishing species, fishing, and then when you want to execute, you just have to go execute. Okay. Okay, I have to give input. Now I forget, but this is the environment. I just want to show you the environment. The console window comes here, and then you can just move it according to your convenience, and then you can write the program. This is like a simple, what to say, VS Code editor or C++ editor that you have in this Spider environment, and that is what is Anaconda is all about. Now coming to okay, I don't have the provision to have Anaconda installed into my system. It is little tricky, and my system doesn't support what to do. Okay. Now for the user, it's better to go for Google Colab. So this Google Colab is a cloud-based. There is a cloud environment that Google supports you or Google gives you a free of cost. But don't go for research environment. So we cannot, even though people say that it is easier, we are not assured. But you can use it for your learning. Go to new notebook. Okay, just you have to log in with your Gmail ID. That's the only requirement, no other case. It gives you a lot of provisions. See, you have the Jupyter notebook here. Okay, just the same way I can write. I'll just give a print statement and just execute. Instead of my system, it is taking time because it is running on the behind of Google, and it needs proper internet support. Yeah, it gets printed, and later on the next process will be very easy. So for the initial case, it may take some time, and then yeah, you can see. Now you can see it is running on the RAM. Okay, and if I want to show you, yes, okay, you can see the hardware accelerator. I didn't choose. I just used CPU because it's a very simple exercise. But you have the GPU or TPU. Okay, it gives you till a particular case it can do. Okay. So that is the advantage of this Google Colab, and this is how you can make use of. This is the way that you have to start using it. Using the Jupyter Notebook or Spider environment for you to start with Python programming, and all you are expected nowadays in this world. Okay, continuous learning is what is expected, and this continuous learning is expected from the machine. Okay, so earlier it was expected only from the human. Now the era is coming where the human being is trying to touch this machine, and this in other case or on the other side, the machine is trying to come closer to touch the human being's mindset. In future, this is how the era is going to be. For that, we have to be prepared, okay, and we have to be proper enough to meet this future. Learning never ends, and thanks for your patience listening. I hope I didn't waste your time and a bit of information will have been conveyed. And if you want to, if you discuss with me, you're most welcome. And I have a list of videos which is self-explanatory with hands-on sessions on my channel. If you are interested, you can make a note. Thanks. Okay, thank you. Any doubts? I'm ready to clarify. Ma'am?
Participants, your queries are most welcome.
Participants, if you have any queries, you can please unmute and post your queries.
Jana all muted தான் வந்திருக்கு.
Participants, if you have any queries, you can give your queries to the speaker. Ma'am, you get a lot of responses through the chat.
Ma'am, just a minute. I'll check.
Suganya ma'am, I have certain queries ma'am.
Yes, ma'am.
Yes, ma'am, what is this self-supervised learning and what is the basic difference we have between supervised and self-supervised learning?
Self-supervised, ma'am. What's the application that you have found, ma'am? For this, did you come across any application for that?
Once again, ma'am. I just...
Because when we move ahead for cognitive application, we make use of some data set that can add up, that can identify the knowledge from itself, okay, so that the data set automatically will get expanded based on the learning. Maybe I think you may be
that all is something which comes under self-supervised learning, ma'am.
what, ma'am? Sorry?
Speech recognition.
Yeah, that's what actually initially we, let's say for example you are training a chatbot, okay, so it will not be trained with the complete, or else we'll take a better example of the service waiting at the restaurant. So the training will be given in only very few basic normal terms. No, it has to move take 4 steps ahead and turn to the right, okay. Likewise only will be trained. But what if an obstacle comes in between? A kid is trying to cross. So that is what is the expectation? That is this, we want the robot to automatically learn by itself. Okay, so when an error happens for the first time, it is like, no, that should not happen. Okay, an obstacle is there. It was not the training that we give, rather we want the machine itself to take it as an input. For the next time, that also has to be trained.
Fine, ma'am. Sonia ma'am, you can unmute and talk, ma'am. Participants, you have any queries, please unmute yourself and put your queries.
also.
Sonia ma'am, you have raised your hand. Can we officially close it? Like,
Yes, ma'am. Can I take leave? Thank
I'll
you.
officially close, ma'am, once
Yes,
again.
ma'am.
Yeah. No issues. Okay.
Ma'am, thank you. Thank you very much, ma'am.
Thank you, ma'am. Thank you for the opportunity.
Okay, ma'am. Vimla, you're going for an official
Yeah,
close?
yes. Good afternoon to one and all present here. No duty is more urgent than that of returning thanks. On behalf of my college and my department, and convey my hearty gratitude to the speaker, Dr. G. Suganya, for sharing her knowledge on the below mentioned topics. Difference between traditional programming and ML approach, datasets, inputs and outputs, machine learning modeling, scales of measurement, types of data, types of algorithm, Python packages, and installation process. I render my deep sense of gratitude to accept the invitation and joining us in this forum today. Thank you so much, ma'am, for your valuable presence and knowledge sharing. We are thankful to our principal, our beloved HOD, and staff members for their constant support and motivation. A special thanks to the organizing committee for their unflinching support and coordination. Our heartfelt thanks to the faculty delegates for their active participation. With these warm words and a kind message, we move to the end of today's FTP and hope to see you all at 10 o'clock and 14/3/2023, that is tomorrow. Thank you all for your participation. Feedback link with attendance is shared in both YouTube and Google Meet. Kindly spare your time to fill the details. Thank you all once again. Thank you.
Thank you, Nirmala ma'am, for that energetic closing.
Thank you.
Thank you, ma'am.
Thank you, ma'am. Thank you, Jessica. Bye.